Can R.A.G AI architecture help improve outcomes for businesses? That's what we're going to be exploring this week on the Data Radio Show. Hello there, and welcome to this week's episode of the Data Radio Show. We're going to be taking another look at the event that we held in Melbourne earlier in the year, this time having a listen to Sheng Lan, Steve Rose, and Sam Redmond, who have all been on the show before, I think, in one phase or another. Who are really informative when it comes to how you can use artificial intelligence in various different ways. And today they're going to give a presentation on how to use R.A.G Architecture or R.A.G Architecture to help improve outcomes for processes within different organizations. It is a long one, so I'm just going to say before we jump over to it, make sure you hit that subscribe button on the channel or like the video. Feel free to share it with others so that, they can get the best out of it as well. Right, let's jump over to the presentation.
All right, so now we have how AI R.A.G architecture can deliver process improvements. I guess this is a topic that is pretty popular at the moment in terms of how you integrate LLMs into enterprise systems. It's something that I think a lot of data managers are getting a lot of questions around. And so Sheng is joining us here as the IBM What's Next specialist. Steve, you're joining us as a data management practice.
Yeah.
You're at the coal face.
I'm at the coal face, on cloud platforms.
And Sam is the 30,000-foot view of what's going on. You want to just briefly introduce yourself?
Sam Redmond, I happen to be his brother, just in case the name, so that is a hatch there, which is Redmond. Next slide. I'm an ex-IBMer, but I'm ex many other companies as well. At the moment, I'm working in the advisory space, connecting strategy and domain expertise with technology and AI. Well, really, it's always with AI that enabled. And that does include a lot of clients, R.A.G as a method of connecting their corporate knowledge with the power of AI.
All right, we'll kick off then. So, over to you.
Yeah, everyone, my name is Sheng. Right now, I work for IBM Consulting as an AI solution consultant. I will give some boring stuff regarding what is R.A.G, some concept. I'm glad we have here for this session, so make it easier for everyone. So R.A.G, I think maybe everyone knows this concept is a retrieval augmented generation. Here is a typical process. The idea is when we get response from a large language model, we're not depend on this memory from the model, because that can be outdated or can be wrong answer. So we provide some trusted information to the model and then ask the large language model to, based on the information we provided, give us the answer. That is the idea to get a better, maybe more accurate, more relevant response from the large language model. The process is like this way. As a user, we ask a question, and this question will be used as a query to search relevant content in your knowledge base or database. Then the search result will, along with the question, sent to the large language model, which is the retrieval plus augmented the question part. Then you have generation from the large language model. So in this area, the search retrieval box here, there have many different techniques. Maybe next slide. For example, the technique for search, we can do keyword search, semantic search, even hybrid search. For knowledge data store, you can use vector store or knowledge graph. For query, you can change your query. So all these different techniques give a different variation of R.A.G. So today I want to introduce two R.A.G patterns with these different techniques. The first one will be graph R.A.G. So the graph R.A.G, essentially, the change is if we call the RAG we have before is the baseline, this one is to change how you store your data as a knowledge graph. The benefit for this one is you think about when you're asking some question that need RAG to understanding globally your knowledge base. The baseline RAG only give you like a very, very small part of your knowledge, like maybe 1,000 words. That one didn't cover this global question. Or you want to asking the question that require to connecting different part of your knowledge, like how many compare A and B. So the in your knowledge base, maybe you have something for A, you have something for B, but you don't have something A and B compare. So this time you're asking the RAG, you need to first search A, then search B, then compare them. So all this global question or question asking to travel around the knowledge base, the graph RAG will very good to answer that questions. The idea is you build this knowledge graph, use AI. So the AI take your knowledge data, then generate this graph based on the semantic similarity. So they call that community of data. So this one is an example for visualization. Different color mean different similar topic. This is the newsletter data. That topic for sports, topic for people, all that kind of in graph way and cluster way to connect to each other. Then this is an example when they do the testing. If I ask what is the public figures mentioned in this newspaper data, this one is like naive or baseline, right? This one is generated by the graph, right? You can see here we have more comprehensive answer. So we have the public figure from different area, but here we just have this kind of like this. They also evaluate this based on different metrics to say graph RAG is a better response. This is one for graph RAG. The next pattern for RAG will be next one.
Can I just ask, so the granularity of what you can get out of the graph RAG is much greater to compare the left to the right.
Yeah.
What are some of the other, I mean, obviously the richness of the answers is probably enhanced. Are there any other?
This is one example, kind of asking the global question. If you ask me to compare maybe sports and another compare traveling about that. Another, the other side, not the benefit, will be the cost to create this knowledge graph. So that is a one-time thing, but it is cost since you use AI to generate all this community data, all these links between data.
Oops.
So
yeah, this
question about the graph. So the graph database is oriented around its nodes, right? The relationships between the nodes. So when you're doing this for an LLM, is it working out what the nodes are, or is it mapping to a model that you create?
It will generate that node. Like for example, Neo4j is the graph database.
Yeah.
The large language model can know how Neo4j to structure the data. They'll generate that data, fit into the database.
Right, but in terms of like in that example, you've got, you know, you might have a movie node and an actor node, for example, and then you map the data, and then entities of an actor in one of those nodes. Right?
Yeah.
So is the LLM working out that you've got a movie node and an actor node, or are you telling it this is a model and you map the data?
We can do both ways.
Right.
The large language model can generate their own category or entity.
Yeah.
Or if you have some idea, say, I know the data have this file, you just try to move the different into this file category. So that is the configuration we can do, use this techniques.
Yeah. I think there's once you're using AI multiple times, so you're using your triple, you're using the inference when you're combining information together, and you use them at the beginning when you create that graph structure. But you're still using the LLM models to work. You just haven't been using multiple times. Next one is more recent compared to GraphRag. We call agentic RAG. So this for this AI agent or agentic concept very popular recently. Essentially, is to add this I call that autonomy into baseline RAG. So AI agent is more like to have their own reasoning, planning, action capability. So think about the RAG use case will be, for example, it will decide if the retrieval part is good or not. If it's not good, it will autonomously initiate another retrieval until that is relevant to the answer. Or if your question is too general, or question is very big question, the agentic part can break down your question into sub-questions, sub-queries to do that. So that is the idea for agentic RAG. And here's some example we can have in your RAG for different agents. Like routing agents mean maybe you have a multiple data source or database. Different data source has different knowledge or different topic. The routing agent can, based on your question, to point to which data source actually go to query. The query planning agent is similar to do this. Do I need to break down the query to sub-queries? Do I need to do the query first, then go to the next one, then have more information to the original query? So all this agent can be embedded into the RAG flow. So more like an agentic workflow. Can do more than just question answer. They can handle more complexity tasks. So that is for agentic RAG. Any question?
Yeah. And you have multiple agents in one RAG and they work together.
Yes. So this one is a single agent example. So this agent mainly to we have agent. This agent we call the agent how to behave for the RAG. Then it will first do the search, right? It will say if I need to do the search, yes or no. If yes, then I will call this tool. Tool is tool retrieval. Then get this retrieval content. Then will decide if this content is good or not. Then if yes, it will generate answer. If the retrieval part is not good, do that one more time. This is a single agent, right? But you can have multiple agents in one framework to do more steps in that flow. If the query are broken down into sub queries, then it'd be the multiple passes for the multipliers. Or if you had different data sources and you needed agents that would so once you route out, then you get to a domain where they bunch of things.
Is that will make it more expensive to use?
Of course. And it's got inference costs have gone down in a little bit logarithmic rate. And most of the efficiency advancements are happening at the inference side, not in the training side. We seem to have asymptoted on training. Like 4.5 is not that much greater than 4, and Grok's great, but it's still not that much better than the others. And it had, significantly more compute behind it. And I reckon in 2020 it'll run out of human created information with which to train anyway. But we're sort of asymptoting on the pre-training piece. So therefore a lot more efficiency coming out of inference, and the inference is actually part of it. So I think you can just assume that you create workflows that have multiple agents to execute. They can be recursive, the same way that you are, and you test it with a colleague, this is the right answer, and then we double check the result. Now it was Excel, we talked about Excel before. You do a check measure, see, right, yes, math one way, right, math the other way, just to make sure the math is right. We'll be able to create workflows that do that from a agentic and a RAG point of view to make sure that we're bulletproof on the answer and the costs in the no one will head to employees.
So it's the ability to cycle through with differing questions. Does that not mean that we are getting through the volume of data available very quickly? And is that a limit? Like, are we hitting the limit? One thing we're talking about how much data we're producing, but actually, are we processing it certainly like reaching the limit for usefulness of that data?
No, because we have recently hit where AIs are writing scientific papers that create new science. They get through the approval process where the science is approved and then they go to control because we don't have any international constructs for science to be authored by a human. And so we just can't author them alone, even though they're 100% written right now. So new knowledge is being created, which will advance humanity. Just won't have been created 100% by human. Not that anything's been up to human, but we might not have been the originator of that. So I don't think it's an issue for us. And some things that an important part of RAG is all around how you vectorize that information, you turn it into this chunks that have semantic relationships so that when you try and retrieve some information to textual to your questions, there is constant advancement that is taking place around that vectorization as well. And so I don't think the close sort of, the efficiency, we're asymptoting on the training, we're not asymptoting on the inference and the improvements on the vectorizing.
Last slide, I think it's a good another answer. So the question is the better or costly? So we're not saying the agentic or graph RAG is better than the baseline RAG is, depend on your use case. So how to make that decision? So will be the evaluation for RAG. So for evaluation RAG, consider this is not like what's the traditional machine learning, the classification yes or no. To do that, there's a three main component in the RAG, which will be your question, the retrieval context, and your response. So there is a RAG matrix in this triad to show different vendor, or I don't think there's a unified matrix yet, but all these different vendor have this kind of a similar pattern to evaluate on these three three pair we have here. Context response is one pair, and the context query response. So the metrics named relevance, context relevance, basically to check is the retrieval context is relevant to your question. Answer relevance is your response is relevant to your question. Response to context is importance to make sure your response is not like make up, is relevant to the context. So all these three is like main metrics you can use to evaluate your RAG. And of course, there is a cost you can evaluate. That comes to another, back to the product level, IBM watsonx. So they have some good evaluation tool already to easily for you to evaluate your RAG solution when you do the development or testing. Also, you can do in production level to monitor that performance. Another concept is more how you develop this RAG. There can be an automated process. Since when you're developing, there's many configurations you need to consider. What model you use, how large trunk you want to split your knowledge base, and what is embedding model you want to try. So here is basically automate this different possibility as an experiment. Then it will be like maybe 10 minutes, 30 minutes, depend on data size. We'll try all the different settings that give you the best one based on your metrics. So that is something automatically to give you a good basis for RAG solution. So that is, I think that is my part from more practical side on the RAG.
I'm so familiar with those embedding domains.
Jumping in a bit.
Yeah. So you were smiling and nodding. I think that part of the reason that there's an experimentation there is that there are multiple ways to build it, depending upon the information that you have, whether that is plain text or whether it's graphs, whether it's images, etc. Then different approaches might with better quality outcomes. It's a little bit like when you were, I remember studying, I had to learn a French problem back in year 11, can't forget it now. So whatever embedding model that I used then, because I just can't forget that at all now. And so tested it the other day with my son's doing French part. But that's part of what we're talking about. We're talking about taking knowledge from the organisation that's unstructured and then chunking it down and putting it inside a database, which is a vector database, such that your large language models can now retrieve it. And that's not necessarily, here's the flavour and shape and everybody does it that way. It's actually, that's part of your RAG process. So you get to sort of experiment on that and implement it. It's also something that you can redo at the time. Sure, there's going to be cost implication, but if something comes out, it means you get better information that allows you to make decisions quicker, then you can repass your source information back through that embedding process.
So I have a layman's question in relation to context windows. And so one of the developments that we've been in the sort of broadly available large language models are bigger and longer context windows. So it's got a memory of the questions that you've been asking. What are some of the advantages of a RAG model in relation to, because I believe that context windows are quite resource intensive in terms of keeping that memory window open, if you like. So I'm just curious, does RAG have certain advantages in terms of bringing that context or that sort of institutional memory that you were describing in terms of the French poem?
Yeah. I think
to the
an opportunity for an AI joke, your question was so long I got lost in the middle, which is the problem with context window, is that although the context windows are getting larger, it seems that the LLM's ability to contain all of that information and provide a rich answer to that, sometimes it misses a whole bunch of detail that was in there. So you can certainly load the book into your context window and ask a question, and it might be good, but there's a lot of circumstances where it's not great. And so a really well-structured vectorized database that uses a RAG model, and they use an agentic RAG model, and part of that might be that it's actually got some chain of thought reasoning, so it's actually recursive and it's going back on itself, should yield better outcomes. I say should because like this is moving things.
So domain-specific knowledge is one of the applications, but also I think we were talking earlier about private or behind firewall.
Yeah, so you can certainly put your private information into a context window and get the LLM to respond to it, but your company's information would probably be too vast for even large windows. So a RAG approach means that you can vectorize all of your corporate information, use a very powerful publicly available large language model, so you didn't have to train yourself, and use that to give you rich answers while still safeguarding all of your proprietary knowledge. And so I guess it was the move from this slide to the next slide I was thinking about, well, what is the future of RAG and where does it sit as these models are getting much more powerful and much more capable, they can consume all human knowledge. And the reality is that in our current architectures, RAG still has a very specific place to hold, and that is because your corporate information sits behind your firewall. And it doesn't matter if you are a small, medium, or large business. If the LLM that you want to use that's the most capable for your business, and maybe it's the most cost effective from an inference point of view to run your agentic workflows, sits outside your, you can do retrieval inside your firewall. So at runtime, you might be passing information out, but never does your corporate information sit out there in the public realm, nor is your corporate information used to train a large language model. So, if you go to the next slide, you can. So this cut off of the graph on the left here, you'll see Rock 3 is at the very top. This is about training compute used to train. Rock was substantially higher. Its performance was not that much better than what we see. 3.7 Sonnet from Anthropic probably outperforms it, replaces the latest from DeepSeek is highly progressive. So what we can see is that the models don't need your corporate information in order to be good. They're already good enough. But what you want them to do is perform on your corporate information, which means you vectorize behind the firewall and maybe have agentic workflows. You use LLMs that are operated by one of the larger branded parties. There's if you haven't been to this site, Epoch AI, they're constantly running benchmarks. Literally, if it's more than 3 weeks old, it's probably redundant at the moment, or something that's actually replaced that information. It's moving quite quickly. The little snippet I've got just behind that is from Snowflake. So Snowflake, quite interesting in their approach. They've always been around structured data, unstructured data, and then separating compute from memory. These are archetypes that sort of play into the AI space as well. And their AI, which is Cortex, is designed to do that hybrid sort of agentic type retrieval where it can go, I want to get fact from my knowledge store, which is going to be your data warehouse at some point, and then I want to go to my vector database and actually get my semantic information that correlates to that. But start with fact, which trustworthy, and then build the semantics around it. Advanced rank theory, like it's so there's, I think this is by Vectorize. So Vectorize Iris, George, trademark there maybe. That's really interesting. So they are multimodal vectorization. There's multiple approaches to this that's coming through. So if you have something that comes through as an image, how are you going to deal with that image in regards to the text? One is you pass the image to an LLM, which interprets the image and creates text that's related to it. You then either store the image in your vectorized database, which means you can vectorize that in chunks, or you store it in a blob somewhere else and pass a pointer to it, and then all that information then goes through your embedding, gets passed into your vector database. And so there's lots of different patterns that people are trying out to work out how we take voice, speech, image, etc., and put them into these vector stores so that your company can actually retrieve them in real time. And then the important one, I like this one, it's quite similar to what Sam put up before, but the number of players sitting in this mix is huge. What I like from this is, if anyone's watched Suits, and it's got Harvey and the other guy, whatever his name was, there's an AI startup called Harvey who actually, it's like having a lawyer on staff, fully digital, and can read through all of your law, all of your case law. In an M&A, you just load them all into your data room and it analyses all of them and finds any discrepancies and issues that we might have. The reason that works is because we've been digitising, moving to cloud, modernising API and microservices for decades, and that sits on top of that entire iceberg of capability.
Yeah, I've seen reports that these legal AI LLMs, effective hallucinate, and there's been a few cases where the judges just look at it and go, dismissed it. What's this case? It looks like it's made up.
Yeah, I'd say I heard some things probably mid last year, and there were cases where people had done it. I'd say we don't. We know that hallucinations take place. People are labelling 2025 as year of aging in the sense that these agentic. So these are generative AI built into an automated workflow that has agency to perform a task. And so part of that might be that you have an agent which is designed to draft and an agent that is designed to QA. And so what that will happen is that QA will look at all the citations and say, right, does that exist in case law? Or go back to the vectorized set of case law and say, find me Redmond versus Redmond. Yeah. When it can't find it, it'll come back, it will run back through. So we're dealing with hallucinations through the chain of thought, most recursive loops, and by agents having agency, it means you set multiple LLMs up to play different roles, and they can actually fact check and QA each other's works. That's what's happening in coding as well. So I mean, architects the code, someone writes the code, someone else reviews the code, someone else with all AIs has written a test framework, and someone is a reliability engineer who's monitoring in production, feeding that through. They can plug into a Slack thread. They can all communicate from the Slack thread, and they can take their actions on the Slack thread and they go and automate them. So I think like that was that. It's one thread or so to make sort of done.
What do you think where will we go? Will it be like you train your model up front with all that property data, or will the trained model retrieve the real-time data and understand it in real time and give you feedback?
I think that training costs are expensive, so there would have to be some proprietary benefit that you would get from training your own model. Now you can the parallel the counter to that argument is that we thought that the closed groups like OpenAI and Anthropic were going to win the race, but the open source community are in hot pursuit. The DeepSeek market that's like $2 trillion off the stock market and rebounded was because they said we can't afford all the compute, we can't do all this work, we're actually going to focus on the algorithms that sit on the back end and how we fine-tune the models, etc. And so I think that time will tell how much they compress. When you've got an AI in your phone, and you'll train them, give it access to your Instagram feed and all of your photos, if you have anything else you're comfortable with that. Well, the whole thing is if it's encapsulated within the bounds that you've set around yourself as an organisation, therefore there's no leakage, then you might be okay with that. It may be lately bound, if you simply just give it access when it needs it. I think that at the moment, the investment threshold is too high, and there's little advantage because the RAG models are actually performing pretty well. That's why I was sort of when I looked at this, it was like, well, RAG's dead. But ask me when you guys have that one of these sessions, which will be a couple of months, with the may have changed. It's moving quickly.
It's a good question as well. So, I mean, if you think about a knowledge system, you add new knowledge all the time, right? And you do similar, right? You embed it in the vector database, and then you have the RAG framework in it. So every time you add, like, let's say 100 new pages, you have to recognize everything again. So it finds new nodes with the system, or can you really cost efficiently add just the new 100 pages?
I know you can just add more content into the vector.
Or it does do a recalculation. At one point, it maybe makes sense.
Don't know that. Like, is there any dilution in the value in your vectorized data if you build that vector database over time? Is that sort of what you're saying? So if you keep adding
maybe nodes were created by the AI.
All right.
With new knowledge make no sense anymore. So they has once to create new
knowledge.
So
in a graph.
Yeah.
In a graph. Look, this is interesting. We were talking about this before. I think that if we start with fact, and so you have a graph for your business, and then you use that to then shape to vectorize your content. If you come up with a new key that provides you greater insights from that unstructured data, which is now vectorized, then it's a business question. It's like how much more value and what's the cost to recompute it all.
But I don't know that the AI knows when it looks at everything again, you should do it differently because so you know that I would have to rerun.
So if you had an LLM that said, I've found a pattern that will increase your profit by $10 million a year, it'll cost you $1 million to fix your database, your database, then you do it. And so I think that I don't think we've progressed enough around those emergent RAG models to know the answer. And I don't like, is there fine tuning that you can apply after the fact that helps to build new graph-based semantic relationships? I'm not sure. Yeah. But they're all statistical weightings, so that it may be a retroactive embedding that you do. But I'm just riffing because I've had a beer now.
Just a really quick question. I just noticed that as a couple of slides that I talk about it, been hearing a lot about model context protocol recently and it sort of keeps going up and down. How does that sort of play into, I guess, this overall RAG?
Well, what it really plays into is agentic workflows and agency. So the idea of having a large language model that has the ability to traverse across your application stack and perform actions. And so you maybe there's like Zapier that was doing automation. Now there's Mind Studio, there's Gumloop, N8N. These were all sort of automation. Now they're agentic workflow because they've got generative AI, large language models that form part of that automation loop. MCP, which is Model Context Protocol, MCP, was all about having a common way for a large language model to talk to any other thing in your technology stack, because they all use this MCP layer to get translation. There was a published attack by a R.A.G team yesterday on forcing approach to that, and so that one. So I think definitely it makes sense if agentic workflows are tripping over because they're having to learn APIs and they get it wrong. Oh, you're right. Sorry, they published a new AI API. I need this one. Yeah, those type of issues, MCP can get over that. So it sort of makes sense, but it just seems like it's not mature yet. So I think that another tech stack is really evolving that rapidly, that you can't deal with those API challenges and just code them into your workflow and then deal with it. Just don't think we don't. Well, apart from IBM, it's I think that IBM is consuming its business with AIs. I don't think. I just don't think that's a challenge that we have in short term. I assume you guys can get this presentation, so I won't dwell on too long. These are just sort of either some things that are happening, have happened because things happen so quickly, or in the future. So real-time high retrieval. So the idea that you could, let's say, have a graph architecture for your vector store that could be real-time case law going in, and your AI advocate, while you're in your hearing, learns what happened next door, and you can now use that argument, Redmond versus Redmond, and you get to. So it's the idea that they're just setting yourself up such that your corporate knowledge continues to evolve based on continuous thread of information. Multimodal, I talked about that. Causal knowledge, this is moving beyond just inference to moving towards causal relationships. One of the examples is your medical record getting connected with the latest in sort of clinical trials and being able to bring them together and find a causal relationship that helps you. Sorry, Shane, do you want me to leave or you're good? Just kind of, I know you're good. Reinforcement learning. So this is what we're seeing with LLMs, is how we're advancing our LLMs. This is part of the approach with R.A.G as well, in that if you find that legal one, someone, your legal community that are relying on your agentic flow are going to case law more than they're going to statute, because that seems to be winning cases, then your R.A.G model can augment to give you more of that information that's going to help you win cases. So it's going to weight it more towards R.A.G, more towards case law. Privacy, so this goes to federated models. This is sort of a really important one. So you start to think about vectorizing data into different places. One of the things I liked about Datavault was the idea that it was, you could have knowledge that sat out there in satellites that didn't break the architecture for everybody else, but only the NSA could see that information, let's say. You can do the same thing. So when you're thinking about privacy, R.A.G having different vector stores that get down together in real time, so the LLM can take in all of that information. And it might be that your health record sits in your domain, but you only want to make that relevant at the time of maybe being a limited practitioner, let's say. So the ability to sort of latency bind, having that information shared around. Last one, energy efficiency. Talk about Grok. So Grok's inference architecture, so the physical architecture is much more efficient. A lot of the effort that's being done in inference, so in runtime, when you talk to these LLMs, is getting more efficient, and it's probably really important because I don't think it's a single economy that can decarbonise at the moment because all new renewable energy is going to compute, which is the issue.
We're being stunned into silence. I'm going to throw a kind of wild card into things. So when you look at full self-driving, for instance, one of the challenges that there is around a complex process like driving is there are cultural nuances between countries. Like that's one of the big things to overcome. How you drive on the roads in Victoria is actually different to how you drive on the roads in Delhi. And what are the norms?
Yeah.
But so
It's really
Loosely coupled.
I thought he was going to say Queensland. I was about to go and say it.
it's cuttingly. Well, and I mean, how you drive on the autobahn is quite different to how you drive on a motorway here.
Yeah.
So one of the challenges that I imagine that there is, and this kind of relates, it's not unconscious bias, but it's the unconscious values and norms, if you like, that might be associated with one organization versus another organization. You could sum those up as being brand values. What do you stand for? How do you see that playing out in LLMs? Because that's one of the big challenges.
Yeah, look, I think that if we think about just digital vision, we have charging up of devices that sit in digital cameras that already have racial bias built in because they don't render skin color the same. So the darker your skin, the less easy it is to identify emotion and other things. Part of it, like you're actually down in the hardware, and so it's almost like the proximity sensors in your car have enough fidelity to manage the right set of information to be able to drive in Delhi, because they need to the panels need to pass each other, cause a small dent, because that's acceptable. And so I think that we have there's these underlying biases that sit in it. So I think that that then will allow you to collect enough of the right type of training data, then train an LLM such that it understands the context so it can perform. So if we step out, we know that for current cars in a singular sort of country like Australia, they're still struggling in that context. And so I think we're a ways off having something that is like universal in that regard. But it's we're only in the first quarter of.
Yes, I suppose it speaks to AI governance. Okay.
Yes, thank you.
So we're going to talk about AI readiness now.
Yes.
Yeah, enough of this far off stuff.
Well, I'm humbled to be sitting with Tom, actually, great raise. But I wanted to raise a topic that R.A.G, if I can say R.A.G is being used as a tool a lot by industry. And a tool like any other, like we say, we talked about power the way earlier, for example, rubbish in, rubbish out still applies. R.A.G is heavily dependent on having good quality structure, good semantic layers, good metadata management, good taxonomies, all that sort of stuff. Because it leverages all of that information to be able to draw the linkages between the various facts and contexts that exist across both structured and unstructured data. I'm by no means a R.A.G expert. Like a lot of people, I can see that it's a highly volatile field of study and application, and it is changing a lot. What we're doing today will ultimately be different in 12 months' time, but a constant that I feel sort of comfortable saying is that having good data. So if we look at R.A.G dependencies, poor quality data does undermine R.A.G. So if you've got poor data, what does it mean? Reduced accuracy and reliability of R.A.G responses. Low contextual relevance, increased operational risk of making decisions based upon flawed data, or you're having your agents with sufficient agency to perform those decisions, again, based on poor data. Decreased user confidence, greater costs and effort. And that cost could extend out to reputational cost and those things as well. So high quality outcomes from RAG rely on several critical factors: quality and currency, good quality data and up-to-date data, metadata and semantics. That's really, really critical. It's important. Understanding what data you have, where it is, how it relates to, how the facts and context relate to each other. Having a structured organisation of the data, that's in your platform, lakehouse or modern data platform architecture, and integration and governance, managing that integration between the various databases, knowledge stores, etc., and appropriately governing. So data platform architecture considerations. So for companies that are looking to leverage generative AI or achieve AI outcomes, what sort of characteristics or considerations should they have when designing and developing a new platform? So firstly, unified scalable architecture. Ideally, in your platform, you're going to want to have a place for everything. So your structured data, semi-structured, your unstructured data, all accessible within one platform. Clearly defined, and scalable, sorry. So recognising the point that Sam made at the start is that there's an ever-increasing amount of volumes of data that organisations are dealing with. Similarly, your architecture needs to be able to scale to accommodate ultimately larger volumes of data coming in the door. Clearly defined metadata and semantics, as I mentioned earlier on, really important that you've got your metadata catalogs, your taxonomies, your semantic layer clearly defined so that you've got consistent meaning across all your definitions, and your LLMs know where to get everything, where to source everything. High quality data management, it's more focused around the data quality, ensuring that data is fit for purpose. Is fundamentally important as well. If the RAG is to perform some kind of operation, then we need to ensure that the data that it's leveraging to make decisions is fit for purpose. Flexible data integration. Now, this is one where Data Vault is very strong in. It's very easy to augment an existing Data Vault with more information to be able to extend it out with more hubs, more satellites, etc. Advanced search and retrieval capabilities, just making sure that we've got the right indexes across all of the data stores so that data can be retrieved quickly, that there are different, extract points within your platform where you can get low warranty data, like nice and fast. High warranty data, yes, it might take a little bit longer, but I know where to get it. It's properly structured and I understand it. These are really important. Robust governance and security. For anyone that's been in the data game as long as I have, the GDPR, privacy, security is a constantly evolving thing and becoming more and more prevalent. Integration with AI and machine learning services. This is an interesting one because an evolving landscape of AI tooling means what does that mean when you say integration with AI? In truth, there's no easy answer for that. There are emerging standards around integration standards between platforms and AI tooling, but it's still very much in its infancy. So I think when you're thinking about building a platform, you want to, maximise the potential for integration is probably what we should be looking at. Performance and accessibility. The performance of your data platform is going to indirectly impact the performance of your AI. If the data is sort of all over the place, then getting that curated vector database is going to take longer. It's going to be more troublesome. It's not going to be an easily sort of repeatable, ongoing kind of process. So just want to talk a little bit about one particular use case that we had. So we had a client that came to us and said, our data platform is not really delivering against our strategic outcomes. We're finding it extremely expensive to maintain. It seems slow, yet we only have small volumes of data. It requires high levels of knowledge. It just seems complexity for the sake of complexity. And so they asked us to come in and say, look, we want a data platform that's going to set us up for the future. On their agenda in the future is AI. So we were quite cognizant that we wanted to try to design a platform for them that was going to facilitate that AI outcome. We went in there, me and Alex, a couple of others, to do a review initially. So we'll try to understand, let's look at the team, let's look at the processes, let's look at the technologies, let's look at the data, try to understand where those complexities are. And so I have to keep referring to this because I did this slide a long time ago, just to make sure that what I'm saying aligns. So what we found through the review process was that there was significant over-engineering. There was a good question that I think Sam, you asked earlier on around tooling, and what does that mean for organisations? What kind of challenging does the ever-growing number of tools out there, what does it provide to an organisation today? And this was a really good example because the client had bought an off-the-shelf tool, a tool that had someone had engineered to kind of do everything. And unfortunately, in doing everything, it actually required a higher level of knowledge and capability than it did to just do it by simpler methods. The tool was actually designed to make it easier, but inadvertently it actually made it hard and slow. It had a lot of functionality in it, but no one actually stopped to ask the question, do we need it? And that's one of the key challenges, I guess. This low data quality and trust leading to siloed analytics. This is something that anyone that's ever worked in a data management space would have seen at one point or another, and scalability issues. They had a roadmap of things that they wanted to do. They just got a new manager on board who was overseeing this. He's got some quite ambitious goals. The platform just was not going to be able to achieve that. Just they were basically dead in the water. So the objective at a high level was to build a modern, scalable data platform addressing the complexity, quality, and the governance issues that they have. We proposed a phased approach where we would say, because they already had something in place, so we don't want to forget that. Right? So let's put in a new foundational architecture, and then let's migrate the legacy systems, and then let's start bringing in, developing and delivering new business-focused products. The key features, it is scalable, it's cloud-based, it's metadata-driven, pretty much end-to-end, supports schema drift. It is a lake and lake house architecture. The governance sort of running alongside. There's several frameworks that we're putting, orchestration framework, a pipeline framework, it's all centralized monitoring with reports. There's also a data quality framework. And interestingly, we double down on that because we also use it as a unit test and regression framework for the platform as well, so that we can test business rules and vault ingestion and things like that. CI/CD. Someone else mentioned earlier on around way of working. If I think of the three main elements that technology always faces, or any problem has, from a corporate perspective, it's always people, process, and technology. We say, here's the technology idea, here's the architecture, and you've already got the people, and we're all going to your team. That's great. But what we're missing was, what's the process? What's the way of working? And we see that a lot when we go to help clients. They say, I want a data warehouse, and give them a data warehouse, and they say, okay, but how do I make changes to that? How do I maintain and manage that? And if you don't have those right processes in place, it's going to seriously impact the longevity and utility of that solution, because it's going to be great from day one, but it's just going to decline very, very quickly. So we had a whole CI/CD framework. We also had a way of working, source control, checking in, checking out, all the line to sort of sprints, all that sort of stuff. So we were able to sort of say, this is what it is, this is how you use it. It was all nicely scripted, and the take-up was super quick. Their ingestion process when we came in was taking close to 4 hours. They had a 4-hour window allocated, and they only had one shot of it. So they had no opportunity to get it right. Had to get it right within that 4-hour window. We got it down to 12 minutes. We just took out all the fluff. I said, well, you don't need all this other stuff because you're just not using it. So just do what you need to get it in. Focus on time to value, getting the data in as quick as you can. And then we also we got the data quality framework around that as well. So that's helped to include improve operational efficiency. Their process that, as I said, used to take 4 hours, now takes 12 minutes. They've got improved data quality. I think that's probably a stretch. If I'm an engineer, so I'm going to be more specific on that point. They have an improved method of measuring data quality. Fixing data quality requires stewardship and ownership and proper governance and all that sort of stuff. But understanding you have a problem is the first step in fixing it. Scalability. So we are now bringing in new data sets. In fact, we redeployed the same platform to within the same organisation to support the migration of a new flying network that they were recently purchased. And the whole environment was put in place within 3 weeks, and we'd sort of already hit the ground running. And so that's really, I guess, talking to the business part. But we're now sort of churning out data products, delivering business value. We've got a long roadmap. And now that we've reached this point, we're now about to start a conversation around AI. In fact, we're involving 3 of us or talking to this client about AI and how we can help them. I guess the message here is AI is only going to be as good as the data you provide. If you've got given rubbish data, you're probably going to get rubbish out.
Hey, I want to thank Sheng, Sam, and Steve for this presentation. It's really informative. I learned a ton from these guys, and every time I sit down and chat with them, honestly, I walk away feeling smarter than I did sitting down, and that's an easy thing to do in many cases. Anyway, thanks for checking out the video. Make sure you hit that like button on the screen if you haven't already, or to subscribe to the channel so that you can keep getting updates like this. Other things as well that'll help you with your data journeys. All right, until next time, live long, prosper, be one with the force, and I'll catch you guys all later.